Welcome back to TrySQL. I hope you enjoyed those challenges. In this section, we'll get our first taste of using the SQL programming language. We now know about databases, tables, and how they're used every day. But how do we actually talk to this database thingy? Well, the answer is simple. 3 letters. SQL, or better known as SQL. SQL is a programming language that allows us to interact with the database. More or less, we provide the database with the SQL code and it produces a result. But is it really that cut and dry? Let's take a closer look. When working with the database, SQL language or code is written as statements that ask the database to perform many different commands. First, some code is written. The database receives the code and processes it. And finally, the data reaches its destination, and the results are given. Simple, right? Let's take a look at our example from section 1. The browser sends out a request, which would be the SQL code, and this goes to the database. The database returns the result and the updated movie showtimes are available back on the website. Here we see that the browser uses the exact same process we discussed earlier to obtain its results. So now we're ready to do a few things with SQL. We have the original issue of finding all of the movie titles being shown at the Gatsby theaters. But let's add a few more tasks to really show how useful SQL can be. First, we want to get a list of all the movies and all of the information about them. Next, we want to find just the title of a movie with an ID of 2. Lastly, we want to retrieve all the movies that have the title The Kid. Let's take a look at a SQL recipe that will return the precise results that we're looking for. To do this, we're going to use a select statement. In the select recipe, we have select blank from blank. The first blank is where we would enter the name of the column from which we want to get some data. And the second blank is the table where the data is located. Additionally, all SQL statements must have a semicolon at the end to complete the statement. Let's tackle the original question of retrieving all the movie titles from the Gatsby theaters. Here we have the movies table and all of its contents. We want to write a SQL select statement that will return a list of all movie titles. To do this, we will use the select recipe and write select title, which is the column we're interested in, and then from movies, which is the table the title column is located in. Only a single column was selected from which to get some data, so the result will contain only this column's data for any matching rows. So now, if we run this awesome SQL code, we'll see that the Gatsby Theater database returns all the requested titles. Since we didn't give the database any more specific requests, it will return all of the titles. Looking at our next task, we want to list all of the movies and the information that goes along with them. Check out this first box of code. You can see here that we can actually select more than one column. This statement would return all movie titles as before, but along with the genre for those movies as well. With that in mind, it's possible to add all of our columns to the select statement as shown in the second box. This would return all data in all columns. What if you had 100,000 columns? You wouldn't want to list all of those out, right? It turns out we have an alternate way of signaling all columns. If we were to run the select statement with the asterisk, we would have all of the movies and their data returned, as if we had listed out all the columns. Pretty cool, right? Alright, so now we know we can go to the database and get all of our data, which is of course useful. But what if we only wanted to retrieve a small portion of that data? We can filter or pinpoint the data we want to find by using a where clause at the end of our select statement. If we look here at our where recipe box, we can see the where clause at the end. Let's show the effectiveness of adding this by now requesting the movie title with an ID of 2. In order to retrieve the title of a movie with an ID of 2, we would include a where ID equals 2 at the end of the select statement. This will allow us to return a more well-defined set of data, specifically all titles to all movies that happen to have an ID of 2. This bit of SQL will first select all columns named title from the table called movies. Next, the database finds the ID column and seeks where the ID of the movie is to. Look at that first box. Is that ID correct? No, clearly not. So now let's look further down the column. With one more step, aha, we found a match, where the ID is in fact to. If we find a row that meets all the conditions of our where clause, the database will pull that row and get it ready for returning. But it's not done searching yet. So we found one correct row, but the database doesn't know if there are any other rows with that ID. So the last two rows are also searched for matching conditions. Turns out though that there aren't any. So now with the search complete, we find that the cell that contains Nosferatu is the data that we're looking for. And since we are only selecting one column right, which is title, then only the data from that column is returned. What if instead we wanted to search for a string of data, such as a word or a phrase? SQL will allow us to do this as well. We can use actual words in what can be seen as a string of letters or characters to search for matching words within that table. Here, we are searching all columns by using the star within the table Movies, where inside the column Title, there is a record that matches the kid exactly. Because we are selecting all data from movies, we know that all records are first considered for the search. The where clause allows us to focus on the column Title as the first filter. And within that column, we find a matching record for the kid, which is the record we're looking for. Something to be aware of when performing searches of this type. Check out how we have the single quotes around the string value. We use these when we are selecting exact sequences of characters that we want to match. In other words, you will need to use single quotes when doing searches of this type. And that is all for section 2. Now it's time for some more challenges. We'll see you in the next section.